number 11. The figure shows an isolated system of three masses. The mass capital M is at rest under the influence of the masses M1 and M2, which are held in the positions indicated in the diagram. When mass M1 is doubled, capital M will remain at rest if R2 change to. There are three masses, capital M, M1 and M2. Capital M, M1 and M2. Now, capital M is at rest. It means the gravitational force on capital M due to simple M1 should be equal to gravitational force on capital M due to M2, equal and opposite. Then they have given that capital simple M1 is doubled. It means we know that gravitational force is G M1 over R1 square. This is the gravitational force on capital M1 due to simple M1. Now, capital M1 is doubled. Therefore, force should be doubled. And capital M should be remain at rest. Then we have to change R2 distance. R1 is this distance. We have to change R2 distance. Then capital F, this force is doubled. This force also should be doubled to the equilibrium of capital F. Then we have to change R2 value. Now R2 value is 2A. We have to change R2 value such that F is doubled. Then we can consider this force. F equals G M2 divided by R2 square. R2 value is changing such that F is doubled. When F is doubled, R2 should be 1 over root 2 because of there is a square term for R2, 1 over root 2 times. Now, initial value of R2 is 2A. 2A should be multiplied by 1 over root 2. Then it should be root 2A. Root 2A is the answer. Then it should be, second answer should be correct, but root is only for 2, root 2A. Then question number 12. As shown in the figure, two satellites A and B of mass MA and MB moves around planet P in circular orbit with speeds VA and VB respectively. The radii of orbits are R1 and R2 respectively. The ratio VA over VB is. I will consider a satellite moving around the planet. Mass of satellite simple M, mass of planet capital M, radius of orbit simple R. Now we can use F equals MA for the circular motion. F equals MA towards the center. F equals MA. The force, centripetal force is given by the gravitational force. Therefore, we can substitute force as G M over R square equals M. We can substitute centripetal acceleration V squared over R. There are three relationships for centripetal acceleration: V squared over R, omega squared R, and V omega. Now we have to consider velocity. Therefore, we can substitute V squared over R. Now we can cancel out M term and 1 R term. Then we can get V is root GM over R. Now I will consider two satellites separately. For the satellite A, velocity of A should be equals to gm constant, radius r, root. For the satellite B, VB equals to gm over its radius is 2r, root. Now we can divide both the equations. VA divided by VB equals gm is cancelling, 1r term cancelling. Then 1 over root 2. 1 divided by 1 over root 2. Then we can get it as root 2. Answer is 3 for the question number 12. Then question number 13. Consider the following statements made regarding the weightlessness experienced inside a satellite orbiting around the Earth. Part A. Weightlessness is due to negligible small gravity at such an altitude. No. When considering the moving satellite around the Earth, we can observe weightlessness due to gravitational force equal and opposite to the force exerted on satellite due to circular motion. We can consider radial equilibrium. Then satellite is accelerating towards the center. We know that there is a virtual force ma opposite to the acceleration. Virtual force means we can observe only relative to the satellite. We can't observe relative to the Earth. Therefore, A is incorrect. There is a gravity. B. Due to weightlessness, the momentum of a person moving inside satellite is zero. Now it also incorrect because of there is a momentum, there is a velocity, tangential velocity for the person, and therefore there is a momentum. Part C. Due to weightlessness, natural thermal convention current cannot occur inside the satellite. Yes, C is true. Then only C is true. Answer is true for the question number 13. Then question number 14. An object weighs 100 Newton on Earth's surface. When it is carried to a height equal to the radius of Earth from Earth's surface, its weight becomes. We know that gravitational acceleration, or we can get it as gravitational intensity, gm over r square. Now now radius is 2 times. Radius is 2 times, then gravitational acceleration should be 1 over 4 times because of there is a square term. Therefore, mg value should be 1 over 4 times on the Earth condition. Then on the Earth 100 Newton at the given point 1 over 4 of 100, it means 25 Newton. Then answer is 2 for the question number 14. Then question number 15. A is a uniform metal rod of length L and mass capital M. The rod B is formed by bending another rod which is identical to A to form an arc of a circle of radius r. A point mass M has been placed between A and B shown in the figure. If A is the magnitude, Fa is the magnitude of gravitational force on M by A, and Fb is the magnitude of gravitational force on M by B, then we have to consider the relationship. We know that when considering these two situations, there are two identical rods in both sides. For this rod, the gravitational force is acting in this direction. Therefore, and distance is increasing, distance is changing with point. Therefore, gravitational force on this direction, gravitational force in this direction should be less than the gravitational force in this direction. But because of this distance is constant always. But we have to consider components of this gravitational force. Therefore, resultant gravitational force due to this arc should be less than the resultant gravitational force acting on this object by the point mass placed at this place. Therefore, Fa should be less than Fb, and both of these values are less than gravitational force due to capital M point mass. Then answer is 4 for the question number 15. Then question number 16. The radius of spherical asteroid is 60 kilometers. The acceleration due to gravity on its surface is 3 meters per square second. The escape velocity of surface of the asteroid is escape velocity at the surface of the asteroid. We know that there are two relationships for escape velocity, but now we have to consider the relationship with gravitational acceleration. Therefore, we can write it 2gr root. Now, we have to calculate escape velocity. Gravitational acceleration is 3, radius 60 kilometers, 60 into 10 to the power 3. 3 into 3, 6, 6 into 6, 36, 36 and 4 zeros. Root 36, 600 meters per second. Then answer is 2 for the question number 16. Question number 17. Figure shows 3 arrangements A, B and C of 4 identical particles with 3 of them placed on a semicircle and 4th placed at the center of the semicircle. With the respective magnitude of the net gravitational force on the particle at the center due to the other 3 particles are represented by Fa, Fb and Fc. Then we have to compare Fa, Fb and Fc. We know that when considering components in A, there are 3 masses like this. Then this gravitational force and this gravitational force. Gravitational force due to this point mass and this point are equal and opposite, then we can cancel out. Therefore, Fa is the minimum gravitational force. Gravitational force on this object is the minimum value. For the second situation, masses are moving towards this side. Therefore, gravitational force should be greater than B, greater than A, and in C situation, gravitational force should be the greatest value. Then we can get Fc, Fb and Fa in this order. Therefore, answer is 1 for question number 17. Question number 18. A planet of uniform density has mass of 2 into 10 to the power 27 kilograms. Its radius is 6.7 into 10 to the power 7 meters. The gravitational potential at the surface of the planet is. We can get the gravitational potential at the surface. V equals Gm over R. Then we have to substitute values. G value 6.7 into 10 to the power minus 11. Capital M is mass of the planet, 2 into 10 to the power 27 divided by radius is 6.7 into 10 to the power 7. But we know that gravitational potential is the work done we have to do to move a 1 kilogram from infinity to considered point. Therefore, it should be a minus value. Then we can cancel out 6.7 and 6.7, 10 to the power 27, then 2 into 10 to the power 20 minus 11, 9, minus value. Minus 2 into 10 to the power 9 joules per kilogram. Then answer is 1 for the question number 18. Then question number 19. If the distance between two masses is doubled, the gravitational force between them decreases by factor of. We know that gravitational force F equals G.M over R squared. When the distance is doubled, there is a square term. Therefore, force should be 1 over 4 times. 1 over 4 times, we have to consider the factor of decreasing. Therefore, we can consider 4 is the answer. Then, second answer is correct for question number 19. Question number 20. The minimum velocity v that a particle should have in order to escape from planet of mass m and r is radius r is given by. Like we have to get the escape velocity, relationship for escape velocity. We can use directly at the infinity the velocity should be 0. We have to get velocity required to move from surface to infinity. Then we can use conservation of energy. At this point there is a potential energy minus Gm m over r squared. So Gm m over r, radius, mass of this object is simple m, mass of planet is capital M. Plus there is a kinetic energy half mv squared. At the infinity potential energy 0, kinetic energy also should be 0 for the corresponding escape velocity. Then we can bring this term to the right hand side. Half mv squared equals Gm m over r. We can cancel out one m term. Then escape velocity is 2 Gm over r root. 2 Gm over r root. Then answer is 1 for the question number 20.